to my class again. This will be the fourth chapter on number, where I will give you some property of whole number that they follows some standard property, and then after some divisibility rule of specific numbers. Okay, so let's start with the property of whole number. Okay, so it says the first property is the closure property. What is that? The closure property says if I add two whole number, I will get another whole number. So if I want to represent differently, I will make it 1, 2 and 3 to make you understand these are different whole number, not the same. So W1, W2 if I add, I will get another whole number. So whole number I know it is the boundary of number. It starts from 0 to infinite, any positive number up to the infinity. Okay, any positive number within this. So if I take the closure property, if I say that whole number plus any whole number is whole number, that means I am using the addition means calculation. For mathematical, I am using the addition of any whole numbers, where two whole numbers added together to get another whole number. So that means addition follows the closure rule for whole number. If I say that W1 into W2 will give you W3, let's say in this case also these are different whole numbers, this also lies true. So that means the multiplication also follows the rule of closure property, because these all are comes under this range. Okay, this will not deviate. If I say W1 and W2 is equal to W3, okay, because whole number is positive, I cannot take any negative number, because this follows and this follows the rule. For addition it is true, for multiplication let's see if it is true for subtraction or not. If I say that I am getting something, some whole number W1 minus W2 W3 is possible, but if the result comes in negative instead of positive, if I take an example here, if I take the example 2 plus 5 is equal to 7, so this lies 2 into 5 is equal to 10, also good. Now if I take 2 minus 5, this is a whole number, this is whole number, but the result comes is not a whole number, because it doesn't lie between the positive frame of integers. So the subtraction rule doesn't follow the closure property. Okay, there may be possibility some of the cases it is true, but some of the cases it is not true. So if it is a deviation from the definition, it would not be a property that always true. So I cannot say the subtraction follows the closure property. Whereas you can take any example for summation and multiplication, you will get always the positive one. Okay, so this, and if I take the division also, if I say W1 by W2, it has to be W3. So it is not always true, because if I take any example of 5 by 2, it won't give you an integer. So it does not follow the rule of closure property, where the result also comes an integer, a positive integer. Okay, so subtraction and division will not follow the closure property. Okay, now this kind of thing I will apply for other properties also. So you remember, closure property is good for addition, it is good for addition, and multiplication. Okay, but not okay for division and subtraction. So like that I will write to make you understand. Okay. The second property comes the commutative law. Commutative. In commutative, if I take the example addition again, so commutative is 2 plus 5 is also true if I reposition the numbers. That means I change the position of the numbers, the result will not change. Similarly, if I take the multiplication, it won't change. So these two also support commutative law. Commutative law says if you change the position, the result will be same. Now if I take the example of subtraction, it will change. The result doesn't follow the commutative. And same case, if I follow the division, it also doesn't follow the rule. So I can say commutative law is not good for same combination. It is good for plus and multiplication, but not good for division and subtraction. Now third law comes associative. Associative. In associative, if I take the example of addition, that means 2 plus, if I do this and if I do this operation, the result does not change. And the same thing, if I say 2 into 5 into 7 is also same as 2 into 5 into 7. So if I change the operation, the result doesn't change. But the same thing if I want to do with subtraction, it won't give you the same result. You see, 2 minus 5, that means if I remove the bracket, it will be plus 7, whereas it is minus 7. So the result cannot be same. And the same thing if I say for division, it also gives you different result, not the same result. Okay. So it's very easy to understand. It is very easy numbers. So I am taking very easy examples so that it will give you clear picture. So division also won't give you, because 5 by 7 it will be a fraction here and it is 2 by 5. So and you divide it 1 by 7. So it all gives the different result. So in associative rule also, the same combination will follow. It will good for plus and multiplication, not good for division and subtraction. The fourth rule comes distributive. Distributive, and this is specific combination, distributive of addition on multiplication, distributive law of multiplication on addition. There nothing subtraction or division is taken in consideration. Only this is applicable for the multiplication, where this is along with the addition is coming. For example, if I say 2 into 6 plus 4, then that also good if I write it like that, 2 into 6 and 2 into 4. So this will give you the same answer. If I add it first and then multiply with the 2, it will be the same as if I multiply the separate with the 2 and then add, it will give the same result. So this is the distributive of multiplication on addition. This is the fourth property of whole number. The last one is the identity. Last one is the identity. So this says, if I multiply whole number with 1, it will be same, and if I add 0 the whole number, it will be same. So this is the identity, so it will not change, means it will be identical. If I multiply it with 1, it will get 1. If I add with 0, it will be 1, because these are also part of whole numbers, so this will repeat, it will give you the identical number if I do this function. So this is the another property. Okay, so this over for the properties of whole number. Then specifically I will describe some of the divisibility rule. Divisibility rule. So one by one I will come to the and I will bring you the divisibility rule. So divisibility rule for 1. That means which number is divisible by 1. That means which number is divisible. It is all. The answer will be all. All numbers are divisible by 1. Second, divisibility for 2. How do I understand any number is divisible by 2? If I get these numbers at unit place, if I get this number in unit place of that number, then it is divisible by 2. Third, divisible by 3. If the number, if I add all digit and the result divisible by 3, then the number itself is divisible by 3. So for this two case I will take some example. Let's say I am having 124. So 124 I can get 4 at last place. So if I want to divide it to, it will give you some integer value. So that means it is completely divisible by 2. So seeing the last digit of such kind, I can say this is divisible by 2. And take another example. If it is 80, then the last place contains 0. That means it has to be divisible by 2. So it gives 40. Okay. So I am taking a smaller example. It also is true for higher example. Now come to this. Now for example I am taking 1, 2, 3. So now if it is divisible by 3, then all digit if I add, I will get 6. 6 has to be divisible by 3. It is divisible by 3, you can see. So this 123 has to be divisible by 3. Okay, take another example of higher order. Let's say 527. Let's see, 5 and 2 and 7. So 14. 14 is divisible by 4, by 3? No. So that means 527 should not be divisible by 3. So let's see if it is divisible. So with the traditional method, if I do 3, 3, 2, 2, 3, 7, 21, 1, 7. So 1, 7 is a prime number, cannot be divisible by 3. So it holds good. If I take example of 589. So what I am getting? 13, 9, 21. The 21 is divisible by 3. It is divisible by 3. So that means 589 has to be divisible by 3. Let's see if it is divisible by 3 or not. So if I do the traditional division of this with 3, I will get 3, 2, 8, 3 and 9, 27, 1, no, 8, 13, no, sorry, it has to be, it is not divisible by 3. because 13 plus 9 is 22. 20 is not divisible by. Whereas if I take 8 instead of that, so it will give 21. So 21 is divisible. Now I will see 21. So 1, 8, it is 3, 6 is 18. So it is divisible. So 588 is divisible by 3 with the same concept. So this for now. In the next video, the remaining number I will show how what is the rule to establish the number is divisible by some specific numbers. So good night for now. I will come to you and with a new chapter for the remaining numbers. Thank you.